So we have another calculus video support for calculus. If you'll be running out of time, of course, I'll be making videos so that you can say that kulang ako ng example. We have examples in the LPs, so I'll be making videos also so that there would be a lot of examples before midterm comes or final comes. So that's where the online comes in, asynchronous. So you don't need not to be on time. But of course, before our quiz comes, you should have seen if you need more examples. Okay, so let's go to our book. So we have a problem here. Find each function uh, for each for each function which is listed. Find first the critical numbers, the open intervals where the function is increasing, and the open intervals where it is decreasing. Okay, so I guess I'll be solving sa sunod. Sige, I'll try. So, kitaan ko lang kung da ko pat oras. So, I'll copy this first so that I would have a basis. Okay. So, so, you have that problem here. For each function, gotta find the critical number. So, let's start first with problem 13. I think I might be needing a calculator for this one. Anyway, I can open just a calculator app. So what is the first steps in finding the critical numbers? Of course, we use derivative and set it to 0. Again, derivative setting to 0 is equal to slope. You are looking for slope which are 0. So derivative is 0, meaning derivative are slopes. So making it 0 is you're making slope 0, and then you can find all values of x or probably also your y, which is a critical value. So for number 13, solutions for this would be, I'll start with, of course, there are three problems here. I'll start with number 13. Functions prime of x. So if I said functions prime of x, I'm already telling that the next part would be a derivative. Derivative with respect to x, because my x is the independent variable. So that would be a 2.3 plus a 5.6 x minus a 1.3 x squared. So you just copy it and put this derivative sign. That's all for the first line. While the second line, of course, you have to find formulas for this. So this is an addition formula. So meaning the addition formula is u plus v. If you have a derivative of u plus v, it just says that you have to distribute the derivative. It's just like a what do you call this, property of addition. So it's just like that. So meaning this thing will be separated, meaning you would have a derivative of 2.3 with respect to x, and then plus a derivative of 5.6 x with respect to x, and then minus the derivative of 1.3 x squared with respect to x. So nag-distribute lang ya for the first line. Then how about for the second line? So this one is the derivative of a constant. This is equation 0. So this would be 0. How about this one? Of course, the 5.6 is a constant, so it will just come out of the derivative. While this one is already the derivative of x with respect to x. Okay, dx. Then minus, how about this one? You copy the 1.3 because it's a constant again. It will just go out from the derivative. And then you will find the derivative of x squared, which is a power formula. You have a 2 closer than 2. Then you copy the x, and then you have 2 minus 1, which is 1 really. So I don't need to put it. And then the derivative of x with respect to x. Then cancel, this one is 1. And this one is 1. So ang 0 kanina, wala ko nagputang. And then, next, so the derivative would be 5.6 minus 1.3 times 2. That is a 2.6 x. 2.6x. So that would be the f prime of x, or the derivative of the function of x. So after that, we set the functions prime of x, or the derivative of x, which is equal to 0. So this means that you have straight line, straight slopes, because those straight slopes, I mean those straight lines, horizontal lines, have a, what do you call this, has a horizontal lines really are having slope which is equal to 0, meaning it doesn't have slope. That's why it's vertical, I mean it's horizontal lines. So you equate functions of x to 0, you're saying that 5.6 minus 2.6x is equal to 0. So from that, we transfer the x. So 2.6x is equal now to 5.6, and then you divide this by 2.6. So this simple algebra, when you transfer it to the other side, it will be a positive. Okay, so review your linear systems, so linear equations. So these are linear equations. So 2.6 divided by 2.6, you would have cancel, you would retain x, and then 5.6 divided by 2.6, may I get a calculator up. So you have a 5.6 divided by a 2.6, so that would be equal to 2.15. So I guess I don't have any mistake. Okay, so that would be 2 times 3, that is 6. 2 times 1 is 2, so that would be a 2.6. 5.6 divided by 2.6, that would be a 2.15. So x would be a 2.15. So that is a critical number. Critical number x is equal to 2.15. So for you to test if what is that critical number, is it decreasing or increasing before and after that part? So we have to know. We usually grab this one. I will pull a what am I going to pull? Maybe I can pull a calculator. So you can test from, since it is 2.15, you can test from 2 to probably 3. You can test 2 to 3, or probably 1 to, you can have x values ranging from what? You can start with 2. You can start with 3, 1. I can start with 1, and then 2, and then you have your 2.15, and then your 3, and then your 4. So I think those are already, that will already give you points to consider, because this is your critical number. You just put C here for a critical number 2.15. So we substitute these values into your equations. So your first equations is 2.3. Maybe I can just pull out my calculator. 2.3, 5.6 x. Maybe I'll pause it and really get my calculator. So I have my calculator. So I'll input the values. For 1, of course, I only have to, actually, I have here a function, a table. So anyway, you can just put this one on this axis here. So that would be 1.3 times 1, that would be 1.3. 5.6 times 1, that would be 5.6. So 5.6 minus 1.3, and then you add 2.3. So that would be a, first is 2.3 plus 5.6 minus 1.3, since you're substituting 1. So the first value really is 6.6 for 1. So this is 6.6. Anyway, I have here a direct again table. I'll be using table function. It looks like this, and then I will just put that value. I put that equation 5.6 alpha x, and then you have 1.3 alpha x squared. See, I inputted it like that, and then I'll start from 1 to 4, and then step is what, 0.15. So 1 is 6.6, and then your 2 is 8.3. Your 2 is 8.3. How about your 2.15 is 8 point uh, um, 8.33. So it goes up. It's only small, and then your 3 is 7.5. So it goes down, and then your 4, so you can see your um, 4 is 3.9. So I think 2 is 8.22, because I don't have 2 here. Maybe I can just substitute. So you can go back because I don't really have 2. So 2.3 plus 5.6 times 2, and then minus 1.3 times 2 squared. So by that, I could calculate that 8.3. So that's already correct. 8.3. And then it goes up a little bit, and then it goes down. So you can see that this critical number is an upper. So it's an upper, so meaning it's a maximum. So if that already goes to infinity, negative infinity, so meaning that would be an absolute max for this kind of problem. Anyway, it doesn't give us. The only problem is we only have to find the critical number, the open interval for increasing, of course, increasing from before this part up to here. So that would be a negative infinity up to 2.15. 2.15, that is a increasing, and then from 2.15 up to a positive infinity, that is a decreasing part, because you can imagine this is bigger than this two. So and then it goes down, so meaning it is doing like this, going to infinity. Okay, having your point here as 2.15, or here is 0. Anyway, so that's how your answer for 13. You identify the open intervals, and you identify the critical number, which is 2.15. So that is 14. Number 12. So oras is 14 minutes. So I'll cut this and for the next videos.